Bismillahirrahmanirrahim. In the name of Allah, who is the most beneficent and the most merciful. Respectable panel, honorable presenters, Assalamu alaikum. Before moving further in the details of the presentation, let me introduce myself. Myself, Engineer Arsalan Ishtiaq, postgraduate student, Department of Electrical Engineering and Technology at University of Engineering and Technology, Texas. I have done my bachelor's in electronics engineering from International Islamic University, Islamabad. Coming back towards the presentation, on the behalf of the community of research and development, being a crew member of industrial automation, going to present a review paper. The title of review paper is a review of system on chip application, Internet of Things and medical. Before moving in the details of the presentation, let me introduce my co-members. Misha Ruj Khan from the Department of Electronics Engineering at UET Texas. Sana Samar from Department of Electronics Engineering, UET Texas. Sayyida Zuriyati Zahra Ali from Department of Electrical Engineering, UET Texas. Inna Safiz from Department of Electrical Engineering, Texas. Kamal Habib from Electrical Engineering, Texas. Now come towards the content of the presentation, through which we have to pass through motivation, introduction, literature review, proposed methodology, conclusion and prospect, references. First one is the motivation. Why I select to review this article. I have selected this article on the basis of a current trending top technology, Internet of Things. What is the Internet of Things? Internet of Things is a cloud-based computation platform which can be accessed globally anywhere in the world by your gadgets. Further details of Internet of Things can be understood by these three examples. First example is the basic example from the medical biometric solutions best serving for the health applications based on the Internet of Things. Why these applications are based on the Internet of Things? Because Internet of Things has the huge space for storing your medical details rather than the USBs, cards, memory cards, hard disks, etc. The proposed principle of the hardware for using this intercommunication between the real-time and Internet of Things is the hybrid network on chips. What is hybrid network on chip and what is the detail of proposed methodology comes later. And the multiple processor system on chips was the previous methodology which is being used for the data collection and storage for the medical systems. Now introduction. In introduction, two main terms, system on chip and IoT and medical relationship. What is SoC? System on chip? System on chip is a hardware upon which different devices like internet protocols, input-output ports, processing units, arithmetic logic units, storage memories, digital and analog converters, signal processing, image processing, and in future machine learning processors are also accommodated on a single plate called system on chip, called chip. Now, Internet of Things and medical, I already explained you the details of the humans related to their health conditions is monitored and stored on that platform, and this platform via online access can be accessed and monitored anywhere in the world. Literature review. In the literature review, what the points I have got. First, I have got the beauty of system on chip IoT systems that any time records can be monitored. Anywhere in the world, anytime you have an open source access to get these records and monitor and present in front of any medical specialist physician. IoT is configuring for resolving memory and security data. Security that from this platform no one can thief or theft, use or get your private data without your permission. The main purpose of the IoT is the remote access of the data. And to involve the optical networking, light-based data traveling and switching on chips. That is why I choose this topic. The main soul of this topic is the basic principle of designing the system on chip is the optical network on chips, which are raising trends to fulfill future low power, minimum latency and ultra high power MPSoCs. Proposed methodology. Basics of hybrid network on chips is the hybrid means multiple, many, more than one. Network on chip, it responds towards the interconnect solutions for the multi-core processors. Means when you have a single processor and when you have a chip having thousands of processors, they have the interconnect issues. Interconnects are the points where the two processors communicate with each other. So there are a lot of problems, various forms of communication between these processors can be lagged. So that is why the solution for this communication gap is the optical communication light. The system consists of four basic modules: laser source, silicon waveguides, microring, resonator and coupler. A little bit detail of this system is going to explain by me. The laser source, lambda 1 and lambda 2 of the different wavelengths produce the different wavelengths of the light and sent over the coupler via waveguides. What are the waveguides? Waveguides are the path in which wave is restricted to move along separate and straight directions. Modulators, EO convergence means electric and optical convergence. For example, a sender sends a signal over an optical network, then electrical to optical convergence using modulator with the different wavelengths are sent over the waveguides in the form of electrical signals to optical conversion and optical signals sent towards the waveguides. From these waveguides, the signal is accepted by the receiver. Then a photo detector detects that a light is falling on that device. So a converter, optical to electrical conversion principle happens, and a sender and receiver receives a complete signal and get the information without any losses. The design proposal, here is the 4x4 mesh type architecture having electrical layers, and these layers have the control paths for the design proposal of the technique used in this paper is the 4+4 mesh type architecture. This architecture has electrical layer and optical layer because we have to need electrical signal conversion into an optical signals because to travel these optical signals over a waveguides without any losses. So in the gray shade we are clearly seeing that 0 to 15 is total 16 mesh type architecture electrical routers are presented, and in the white squares optical router representation total number is the 16, and vertically lines your thing with the visual representation of the waveguide from which an sender sends an electrical signal which is being converted through modulators in the optical signal form and sent via waveguides towards the receiver. Receiver receives an optical signal in the form of light over the photodetector, and photodetector send this signal in the form of electrical signal after conversion towards the receiver. In this way a receiver gets the complete information and complete signal which is being sent by the sender. A question arises, why a mesh type architecture used here? A serial communication or parallel communication can be used, but they have their drawbacks. In the serial communication, the drawback is if only serial path exists between these optical routers and electrical routers via waveguides, then if the single router, for example say fifth one router, will be unfunctional or faulted, then all of the communication will be interrupted. Means that no signal can be sent or received between the sender and the receiver. While here in this topology, when an array-based communication is used, then any one of the signal sent from the electrical routers toward the optical router via different waveguides, these waveguides are vertically presented, then each of the router, either electrical router or optical router, have the multiple paths to send their signal toward the receiver. So that is why if fifth one router is being vanished or unfunctional here, then 0 from 0 signal is moved towards the 4 to via 8 and 9 and reaches towards the destination 10, and for any or from 1 to 6 and 10. This is the beauty of the design proposal using the mesh architecture. Now the sequence of the design proposal in the hardware. From the top you can see that there is a heat sink, then electrical layer from electrical signal which is being sent by the sender, and an electrical to optical interface that there is a device which is being used for the conversion of electrical signal to optical signal, and optical layer from which an optical signal leaves to the way towards the waveguide and reaches to the sender. There are some results of the previous multiple read, multiple write and single read operations, single write and multiple read operation, and multiple write and multiple read. Means a sender sending a signal single on the our waveguides, and receiver receives a multiple waveguides. Then in the different methodology, a single write operation means a single signal is sent multiple times read, multiple write, and multiple read. A question arises how a single signal is being sent and multiple write or multiple read function is performed here. It will be performed that you have seen that a signal is of different frequencies going to send over a waveguide. So single write, multiple read can be possible. Similarly, multiple write and multiple read operations, and these are the results. You are reviewing over here the results of the topology. And figure shows laser power. Now those are the system on chips. Here is the optical network on chips and hybrid network on chips results is being shown here. You can view that. These are the M1, quad, pseudo are different microprocessors, Karaman, Lagnan. The highest rate is the attack rate for the hybrid network on chips. Now in the field of medical health monitoring system. Now in the patient health monitoring system, how IoT is used, the sequence of IoT and the health is here using by understanding a simple example of machine learning. That first step in the machine learning is the data acquisition, segmentation, pre-processing, feature extraction, classification and results. After getting the results, I have to store it onto the network on chip based hardware using Internet of Things protocol for the remotely accessed. So ECG signal reconstruction, a basic simple example is the ECG signal electronic cardiogram of the heart signal, where we are using CS encoder and PRDs. The data usage for experimental works is taken from the PhysioNet MIT database web access. Different patient values record from MIT database is here recorded. This is the relation design of the system for the MATLAB processing in medical field when a signal is off towards via using CS communication sensor and would convert into the other form of signals, and hardware is going to read these signals and providing their outputs. Classification of signals here, randomly quality of signal of the PRD, probability random distribution function. And now towards the conclusion and prospects. Conclusion and prospects are that the Internet of Things is the current rising trend for the data storage, and system on chip is moving towards from hybrid system on chips towards the hybrid network on chips, means multiple processor are on chip at risk. Now this risk is being removed by using the network on chip. These are the references from where I reviewed the article and get the information. For further details, you can read these articles.